Another way that we can demonstrate adding and subtracting and combining angles is with an angle bisector. So the word bisect means to divide into two equal parts. And the key word here is equal. Okay, and we'll see how it looks. So, for example, let's say we had a single angle. Okay, and we had a bisector. So a bisector, if it's split in the middle, would mean that it would have to be a line that's somewhere in the middle. So let's say we had a line going straight down from the vertex outward. Oops. Okay, so this would be our bisector. Now, just like the bisect definition says, it divides into two equal parts. A bisector, let's put that on the side actually. Creates two congruent angles. Okay, so there's a new word here, congruent. Okay. Congruent means that two objects, if you're comparing them, their measurements are the same. Okay, so congruent means objects with the same measurement. Okay. So that means our two angles are going to be congruent by this angle bisector. So the two angles labeled would be congruent. So let's say this was 35 degrees, the other one would also have to be 35 degrees. Okay. This is also a symbol that we use for congruent in the diagram. We just use many arcs. Okay. So since they both have one arc, they would be congruent. If they had two arcs, those two would be congruent. Okay? And we'll go into a little bit more about congruent angles later in other videos. Okay, let's go through a couple examples of bisectors. Okay. Okay, let's see that. So we have something that looks like that, and I'm going to go ahead and label them for you. So we have angles that are labeled A, B, C, and D. So this purple line here is our angle bisector. Okay, again, we can never assume things, so in my problem I will tell you that it is a bisector. Okay, so BD, I'm calling it a ray, so ray BD bisects angle ABC. Okay, so I'm telling you that this purple line will bisect ABC, meaning it will split it into two equal parts. Okay. I'm also going to give you that measurement of angle ABC equals 74 degrees. Okay. want to find measurement angle ABD. So let's go through that. So we know that BD bisects ABC, meaning that we have two angles now that are congruent. This angle here and this angle here. They are congruent. We also know that ABC is 74. ABC is the entire angle. Okay. Now, if the entire angle is split up into two equal parts, we should be able to find ABD. ABD is 1/2 of the entire angle. So we can take 74 degrees and we can divide it by 2. 74 divided by 2 equals 37 degrees. That means measurement of angle ABD equals 37 degrees. Okay. One more example. Let's do an alternate scenario where we use bisect. Okay. So again, we have our purple line as our bisector, and we have our points on our angle, and I will label them X, Y, Z, and then there's T in the middle. Okay, so let's give some information on this. So YT, ray YT bisects angle XYZ. It is also given that measurement of angle XYT equals 41 degrees. I want to find measurement of angle XYZ. Okay, so let's go through our information again. YT bisects XYZ. That means we have a bisector, so we will have two equal angles. These are congruent. Let's see what else is given. Measurement of angle XYT is 41. XYT. XYT. Okay, so that means we have this as 41 degrees. Now, since 1/2 is 41 degrees, the other half will also be 41 degrees. Okay. Looking at our final answer, we want to find the measurement of XYZ. XYZ is the entire angle. So in order to do that, we can add them together, 41 plus 41, or you can just do 41 times 2. Whichever way you want to do, you'll get the same answer. Okay, 82 degrees, 41 plus 41, and then 41 times 2 equals 82 degrees. Okay, so you see you'll get the same answer there. Okay, and that's another application of where we